In this video, I want to have a look at one example of curve sketching with a discontinuity. So we're going to sketch the curve y equals x squared minus 4 all over x minus 2. So the first thing you should notice is the domain of this function. We cannot have x equal to 2 because that would give us a 0 on the denominator and we can't divide by 0. So we need to know that our domain is x cannot equal 2. Alright, the next thing I want to have a look at is this function can actually be simplified. So we could write that as y equals, if we factorize the top, it's the difference of two squares. So we'd have x plus 2, x minus 2, all over x minus 2. And then our x minus 2's can cancel out, and we just end up with y equals x plus 2. So this function simplifies to this, and we know that this is a straight line with gradient 1 and a y-intercept of 2. So that means that our original function is going to look like this linear function, except it cannot have x equal to 2, so it's going to have a discontinuity at that point. Before we sketch it, I'm going to go through and do a few more things just to get a bit more detail and check that we're on the right track. So I'm also going to find my intercepts. So to find my y-intercept, I'm going to set x equal to 0, which would give me y equals 0 squared minus 4 over 0 minus 2. Which would just give me minus 4 over minus 2, or 2. So my y-intercept is y equals 2. To find my x-intercept, I'm going to set y equal to 0. So that will give me 0 equals x squared minus 4 over x minus 2. Now that means that the numerator has to be equal to 0, or you can think of it as multiplying both sides of that fraction by x minus 2. So I'm going to have x squared minus 4 has to equal 0, which means that x squared is equal to 4. Which means that x should be equal to plus or minus 2. But we already know that x cannot be equal to 2, so that means it's just x equal to negative 2, so not plus or minus in this case. So we have a y-intercept and an x-intercept, we know the domain restrictions, and we know what that function is going to look like. The other thing that it's good to check is the symmetry, so whether it has odd or even symmetry, or it might be neither. So to do that, we're going to find if f of x is our original function, is x squared minus 4 over x minus 2. We're going to find f of minus x. So in our case, that would give us minus x squared minus 4 over minus x minus 2, which would just give us minus x squared is just the same as x squared. So we'd have x squared minus 4 over minus x minus 2. And that's not equal to the original function, and it's also not equal to a negative outside of the original function, so therefore it's neither odd or even symmetry. All right, so now let's have a go at sketching this. So sometimes it's good to have this drawn up somewhere else on your page and to be adding all these things as we go through. So we know that it's having a y-intercept of 2, an x-intercept of minus 2. We also know that there's a discontinuity at 2. So if we were to sub 2 into this function here, we'd end up with 4. So 2, 4, there's going to be a discontinuity, so an open circle. But otherwise, our function, this original function, is going to look exactly like this one. So it's just going to be a straight line going through those points. And we know that it has a gradient of 1. So of course, you guys should be using a ruler for this as well. Now, if you use graphing software to graph this function, you can see that it actually just gives us this straight line here, and you can't see the discontinuity like we've drawn it in ours. So we've made it obvious that that discontinuity is there at x equals 2, but when a graphing program does this, because we can get infinitesimally close to x equals 2, it's not possible for that program to show that that point exactly doesn't exist. All right, so that's having a look at curve sketching with discontinuities.